Sorry I couldn't record the first two slides, but I am back. And I actually recorded this whole thing without sound, but however when it was in my editing software, it became all blurry. So I have to record it with the sound to make it easier on myself. Anyways, number 33, mathematical connections. Write a function b for the volume of the cubic yards of the right circular cone shown, and write function w is the volume in cubic yards of the cone when x is measured in feet. So instantly you will know that 1 yard is equal to 3 feet, therefore b of x has to be equal to a w of 3x. W of 3x. We're going to write a function v of this right now. So the area of a cone is 1/3 pi r, right, 3x squared, and then multiply that by the height, so x plus 3. So then we have 9x squared, 1/3 that's 3x squared, 3x squared pi, x plus 3, I should have done 3 pi x squared. And then that will be 3 pi x cubed plus 9 pi x squared. And that is the, I think, yeah, that's the v of x. Now in order to get w, we have to substitute v of 3x. Sorry about this. V of 3x equals w of x, not v of x equals w of 3x. So w of x is equal to 3 pi, and then we've got to put 3x in there, cubed plus 9 pi 3x squared. So 3 cubed, 27, that's 81 pi x cubed plus, and then 3 squared, 9 times 9 is 81, so 81 pi x squared. So it's 81 pi x cubed plus x squared. Did I do that right? 9x squared, 9x cubed plus... Did I put the 3x squared, 9x squared? Okay, I did that right. 81 pi x cubed plus 81 pi x squared. Find and interpret w of 3. W of 3 is just, you plug that in, so 81 pi 3 cubed plus 81 pi 3 squared. 81 pi 3 cubed is 2,187, and then 81 pi 3 squared is 729. You add them together, you'll get 87 plus 29 is 116, so 2,915 feet cubed. So W of 3 is 2,916 feet cubed. Volume is 2,916 feet cubed. That's basically what they mean by interpret. So how do you graph a polynomial equation? I need to make this. Right? So you use zeros. So we've learned essentially all of the tools that you need to graph a polynomial equation already. So all you really need to do is use your zeros, use your solution, x-intercept, use your y-intercept, use common point, and use the end behavior. So for example, zeros in this case would be -2, 1, and 3, since all of those will make the equation 0. Is you 1, 2, 1, 2, 3. So 1 is a 0, 3 is a 0, -2 is a 0. And it'll go from the bottom side. It's 1/4, so it'll be a little flat. But we don't really need to know about that. So we'll take some points in the middle, right? So -1, 2, and 0. Yeah. and 0 is the y-intercept as well. So these are some points in the middle of these 2 points. So if you put 0, everything's just going to be is. So 1/4 times 2 is 2/4, negative 2/4, positive 6/4. So let's say it's like right there, right? Let's say it's right there. And then negative 1, if you put negative 1 in there, that'll be positive 1, negative 2, and negative 4, so that'll be positive 2. That'll be probably there. And then so I'll make an x f of x table, x f of x table, right? 0, you'll get 6/4. Negative 1, you'll get 2. And then 2, you put 2 into the equation, you'll get 4, 1, and negative 1. So you'll get negative 1. So it'll be right about here. So then we can kind of sketch this graph. Be somewhat like this. There you go. And then that's the polynomial equation graph. Simple. Simpler than you think. And the y-intercept is that, and the common points, and the end behavior is down to up because the thing is positive. So if it's positive, it has to be from the bottom to the top, right? It has to be the bottom, from bottom to the top. So there's something to know. Something it's quite useful to know, but it's not necessary. So this is called the location principle. It's an application of something you'll learn in higher level math called the intermediate value theorem. But if f is continuous on this interval a, b, where f of a is smaller than 0 and f of b is bigger than 0, and a is and n is in the middle of a and b, so a number n, then some f of n will be equal to 0. So for example, we have f of 5. F of 5 is equal to, no, actually, this is a little tough. We have f of x is equal to x minus 3, x plus 2, x minus 1. Okay, and then I'm going to solve this out. That will be x squared minus x minus 6, and then multiply that by x minus 1 will give you x to the third minus x squared minus x minus 2x squared minus 7x, no, wait, yeah, minus 7x plus 6. Right? So that's going to be your equation.
Yeah, I have it right.
And
I got it.
let's say we don't know the zeros. Let's say we don't know the zeros, okay? We do from 0 to 2. So what's f of 0 in this equation? F of 0 is 0, 0, 0 is 6. It's the y-intercept. Well, what is f of 2 in this equation? F of 2, we plug that in. 2 cubed is 8 minus 2 times 2 squared is 8 minus 7 times 2 is 14 plus 6. 8 minus 8 minus 14 plus 6, that's negative 8. So f of 2 is negative 8. So this theorem basically says that since f of 0 is 6 and f of 2 is negative 8, there has to be something in the middle of that 0 and 2 that is equal to 0, and in this case it's 1. So if the function is continuous and there's a point that's higher and there's a point that's lower than 0, there will be one input in the middle of those two inputs that is exactly equal to 0. So that's something to know. I don't think it'll be tested in your final or whatever, but that's something good to know. Yeah, let's keep going. So this will be tested on your final or whatever it is. It's called even, odd, or neither function. So a function is even if it's reflective upon this axis right here, and a function is odd if it can be rotated 180 degrees and it's the exact same shape. So the function is an even function if f of negative x is f of x. So when you think of even functions, it's like normally 2, 4, 6, that's even numbers, right? So if you can look at it, for example, x cubed minus 9x, they all have odd numbers, so they'll most likely be an odd function, because we'll test it out right now. Okay, so f of negative x is equal to negative f of x. So let's do negative x cubed minus 9 times negative x, is that equal to negative x cubed minus 9x? Okay, so now if we do negative x cubed, that's just negative x cubed, right? Negative 9 times negative x, that's plus 9x. Is that equal to negative x cubed plus 9x? Yes, it is. So since these have odd polynomials, they're always odd. Since they're odd, they're good. They can reflect upon the y-axis, and it would be odd. Let's do the next one, 5n plus 3. Now this has an even. This is basically n to the 0. N to the 0. This is n to the 1, right? N to the 0, n to the 1. Shh. N to the 0, n to the 1. So they have an odd and an even. So since they have an odd and even, they can't be a totally even function, can't be an odd function. Therefore, they have to be a neither function, right? Right? Okay, let's test it out. So f of negative x equals f of x. So is 5n plus 3 equals to 5 times negative n plus 3? No, it does not. Because it's negative 5n plus 3, not just 5n plus 3. So we do, okay, so is 5 negative n plus 3, is that equal to negative 5n plus 3? No, it does not, because then the 3 is negative, but in this case the 3 isn't. So it is a neither. That's odd, right? These all have even numbers, so guess what? They're an even function. You can test that out for yourself. These all have odd numbers. This is technically a 1, so it's an odd function. So if all of the numbers of functions is odd, it's an odd function. If it's even, it's an even function. If it has both odd and even, it's neither. Okay. 49, writing. Well, we don't do much writing because writing sucks, but why is the adjective local used to describe the maximum and minimums of cubic, sometimes not required for quadratic functions? So this, let's draw a cubic function right here, right? Cubic function.
I'm trying to get like a 15.
Right, there you go. That's a generic kind of fat cubic function, okay? What's the maximum and minimum of this cubic function? It's infinite. That's the global maximum. That's the global maximum. The local maximum is these. These are the local maximums and local minimums. It's not interesting. It really isn't interesting. If you look at your global maximums of cubic functions or functions with an odd function with an odd number, because like an odd leading degree, because it's going to be infinity, and negative infinity, or both infinity and both negative infinity. Just infinity and negative infinity. So whereas quadratics, you can use the global term because it's just going to be like this. See, even though the maximum is infinity, the minimum is not infinity. The minimum is not negative infinity. The minimum is at a certain vertex, at a certain point. Therefore, you have to use local when referring to the cubic functions, but you don't have to use local. You can use global when you refer to the regular quadratic functions. 50. How do you see it? The graph of polynomial function shown. Find the zeros, local maximum, local minimum, and the values of the function. What are the zeros? The 0 is right there, and the 0 is right there. So is that 0, and is that negative 3? And 0 is also the local minimum of the function. 0 is the local minimum of the function. 2, negative 2 is the local maximum of the function. So negative 2, 4, I think, and then 0, comma 0. Compare the x-intercept of the graph is y equals f of x and negative y equals negative f of x. So the x-intercept is the zeros, we say the zeros. So we can do y equals negative f of x, as we learned, is just a reflection upon the x-axis. So we can draw that kind of easily right now. Okay, that was kind of bad. There you go. That's the reflection right there. But y equals f of x, y equals negative f of x intercept. We have the exact same intercept. However, the maximum minimum value functions are also reflected. So negative 2, 4, instead of negative 2, 4, it will be negative 2, negative 4, and 0, 0. So these are going to be the same, but these are different.
No, it wasn't. The next time was like here or something.
And that's going to be it. That's going to be it for today's episode of, I thought I had another slide because there was page 7 of 8 right there. But that's going to be it for today's episode. If you like it, if you don't want me to do any course suggestions, I know I'm kind of busy with stuff right now, teaching and whatnot. But if you want any course suggestions, suggest it to me. Okay, and I'll see you next time with another, I think it's going to be nth roots or fundamental theorem of algebra.